You've seen it every day of your life, but maybe never asked why. The sky above you is bright blue, soft, and endless. But if you travel far enough up, that blue disappears, and space is nothing but black. The same sun shines on both, so why do they look so different? You lie back and feel the warm air on your skin. Above you, sunlight passes through the air, changing in ways you can't see, until it fills the sky with color. That blue seems real, yet it's made by tiny things in the air and the way your eyes work. Just beyond the air's edge, there's no scattering, no soft colors, only the deep black of space. A thin layer of atmosphere is all that stands between the two worlds. Tonight, you'll drift slowly upward, from the familiar blue you know to the silent dark above it, and discover how the same light can create two such different skies. It begins not with a wall, but with a breath. The air moves softly against your skin, invisible, unshaped, yet it feels like it holds something vast above you. You lift your gaze, and there it is, the expanse of blue. It looks solid in a way that feels ancient and certain, a roof stretched tight across the world. Your eyes can't quite pierce it, and so a part of you believes it must be there, as real as stone, as present as the ground beneath your feet. Once, long before you, people trusted that feeling completely. To the earliest sky watchers, the heavens were a kind of ceiling, a perfect dome, perhaps made of crystal or polished metal, its inner surface painted with the blues of daytime and the tiny lights of night. The stars, in that vision, were fixed jewels hammered into place, unmoving except for the slow daily spin of the vault itself. The sun and moon rolled along grooves in this great shell, a cosmic machinery hidden from mortal eyes. Such an idea made sense when you looked with only your senses. The sky doesn't seem to swirl around you because the earth is turning. It feels like you are steady and the heavens are what move. And that dome is always there, day or night, the same curve holding everything in. Without the tools to look closer, without the patience to question the ordinary, the illusion became truth. But truth, over time, has a way of slipping in like light through a crack. Mariners began to notice that stars shifted with their journeys. The North Star sank lower toward the horizon the farther they sailed from northern seas, hinting that the world was curved and that the dome above might not be fixed to it. In the dry heat of ancient deserts, travelers saw the blue fade into pale white at the horizon and wondered if the color was thinner there, like worn fabric. And high in mountain air, climbers found the blue darken toward violet, as if they were nearing the edge of some celestial roof. Eventually, through experiments and observation, the sky's true nature revealed itself. There is no dome, no ceiling, only an ocean of air. The blue is not painted on, not a fixed surface at all, but a thing the air itself makes when sunlight passes through it. You can stand in that thought for a moment. The color above you is not an object, but an interaction, an event that happens over and over again, every time light touches atmosphere. The air you breathe is mostly nitrogen, with a generous portion of oxygen and smaller traces of argon, carbon dioxide, and water vapor. These molecules are so small that they are invisible to your eye, and yet they do something extraordinary with light. The sunlight arriving from 93 million miles away contains all colors, reds, greens, blues, and beyond, each with its own wavelength. These colors do not scatter equally. Shorter wavelengths, the blues and violets, are more easily bounced and jostled by the tiny molecules of air. Longer wavelengths, like red and yellow, pass through with less deflection. The effect is called Rayleigh scattering, named after the English physicist who described it in the 19th century. But the phenomenon itself has been happening since the first sunrise on Earth. Each particle of air is like a miniature prism that favors certain notes of the sun's symphony. As billions upon billions of molecules scatter the blue light in all directions, your eyes receive that scattered blue from every part of the sky at once. That's why the color seems to come from everywhere, not just the path of the sun. The violet wavelengths scatter even more strongly than blue, but your eyes are less sensitive to violet light, and some of it is absorbed by the upper atmosphere. So blue becomes the dominant voice in the chorus. This is not the deep, dense blue of pigment, but the soft, shifting blue of light made by the sky itself, a color that can brighten to a pale silver in hazy air or deepen to sapphire in crisp, dry weather. Standing under it, you are part of the same physics. The same molecules that scatter sunlight into blue are the ones that fill your lungs, the ones that carried the breath of someone else before you, perhaps yesterday, perhaps centuries ago. The air is not just an empty space between you and the stars. It is a shared, living medium, a bridge between bodies and moments. It's easy to forget this when the day feels ordinary. But imagine, for a moment, the strangeness of this arrangement. The very same sunlight that blinds in its direct beam turns to something gentle and diffuse when scattered. It becomes something you can look at for hours without pain. It becomes a roof made of light, not stone. If you could rise up through it, you would feel the illusion change. As you ascend, the number of molecules above you lessens. The scattering weakens. The blue light grows thinner, diluted by black. Astronauts describe the transition as swift but profound. One moment, the world still wears its blue halo, and the next, it is gone, replaced by the naked darkness of space. From up there, you realize the blue is a skin the Earth wears, one only a few dozen miles deep. Yet here, at the surface, it feels boundless. And perhaps that is part of its gift, to make the infinite seem near, to make emptiness feel full. You are not looking at a structure, but at a performance, the light and air working together to show you a color that lives nowhere but in the act of seeing. The ancients may have been wrong about the dome, but they were right about one thing. The sky is a thing worth wondering at. Its color may be explained, but the explanation does not take away its beauty. If anything, it adds another layer, that something so intangible can be so precise, that chaos at the scale of molecules creates something steady enough to guide the rhythms of your day. You let your gaze drift across the horizon, noticing the subtle gradient, deeper blue above, fading to a whitish glow near the ground. That's because you are looking through more air when you look sideways than when you look straight up. More air means more scattering, which means more mixing of colors, which washes the blue into a paler tone. Even the shape of the Earth itself plays a role in how the sky changes as you turn your head. In that awareness, the dome disappears entirely. There is no hard edge, no painted ceiling. There is only openness, carrying light in ways your senses can drink in without ever touching it. You close your eyes for a moment, breathing in the invisible particles that scatter the day's light above you, and when you open them, the blue feels even more alive. Somewhere, far above, those same molecules are busy in another way, bending the sun's light into its other, hidden colors. They are preparing the sky for changes yet to come, changes you can feel in the slant of the light and the slow deepening of shadow. Soon, the air will let go of its hold on blue, and another palette will take its place, painting the day toward its quiet ending. It begins with warmth, pouring through the thin air above you, sunlight that has traveled across 93 million miles of space without touching a single thing, until now. It slips into the ocean of our atmosphere, and, in that instant, its path changes. What was once a straight voyage becomes 1,000 sudden turns, invisible ricochets against the smallest of dancers, the air molecules themselves. You feel yourself drawn into that dance, as if you could follow a single ray of sunlight all the way from the sun's surface to your eyes. At its birth, it is part of a crowd, a spectrum of colors so wide your vision can only hold a fraction. Each is a wave, its own length and rhythm, cresting and falling through the vacuum. The reds are long and lazy, like swells rolling in from a calm sea. The blues are short and quick, like ripples chasing each other across a pond. When this river of light meets Earth's atmosphere, it meets nitrogen and oxygen, tiny, unseen shapes endlessly in motion. To light, they are not just empty space. They are scattered islands in a great airy ocean. And here, physics writes its quiet rule. The shorter the wavelength, the more easily it is knocked from its course. The quick, restless blue waves stumble into these molecules again and again, tumbling in all directions. The reds and oranges pass more smoothly, less easily caught, slipping ahead while their higher energy cousins are spun into a cloud around you. This scattering is not harsh or chaotic. It is graceful, a ballet written by chance and by the laws of electromagnetism. The air does not choose blue, yet blue becomes the most visible because its light is stirred into every direction at once. If you could see from above, It would be as though the sun's rays poured in white and bloomed into blue mist, wrapping the planet in a luminous veil. You let your mind sink deeper into the light itself, into the way it behaves as both wave and particle. Imagine a photon, a single packet of energy, born in the heart of the sun through the crushing dance of hydrogen atoms becoming helium. It has waited thousands, even millions of years to escape the sun's dense interior, bouncing from particle to particle within that brilliant furnace. Then, finally free, it streams outward at the universal speed limit, racing across the emptiness. Its journey through space is silent. No air to scatter it, no friction to slow it. A pure, unwavering line toward our small blue home. Then, within the last breath of its voyage, it meets an atom of oxygen, and the world changes. That tiny collision flings it sideways, perhaps into the ocean, perhaps into the leaves of a tree, perhaps directly into your eye. That one photon might have begun its journey before humans walked the earth, only to end in the moment you looked up at the afternoon sky. This is why the air feels almost alive when you think of it, a thin, restless medium that turns the sun's invisible richness into the visible blue you know so well. If the atmosphere were perfectly still, light would still scatter, but the effect would feel colder, flatter. Instead, every gust, every whisper of wind, stirs the molecules, changing the pathways of countless photons, making the blue shimmer and deepen as clouds pass or as the humidity shifts. Your breath, too, becomes part of this. Each exhale adds more molecules to the air, and while it is imperceptible on a grand scale, there is a strange intimacy in knowing that the sky above you is not static, that you and every living thing are woven into the same thin shell that bends the sunlight. Some days, the blue is so bright it seems painted on, as if the dome of the sky were solid. But you know it is the light itself you are seeing, the same white sunlight that, in space, would seem almost colorless. Astronauts looking down from orbit don't see a dome. They see the delicate halo where this scattering happens, a glowing line hugging the curve of the planet. From their vantage point, the rest of the sky is already black. There is a secret beauty in this, the fact that blue skies exist only when viewed from within. Outside the atmosphere, there is no sky, no veil, just stars, even in full daylight. Our blue is an inside view, a phenomenon tied to our very position, like the inside of a seashell that hides its colors from anyone looking from the outside. As you imagine the photons swirling, you may feel a kind of kinship with them. You, too, are shaped by the medium through which you travel. Life bends you, refracts you, sends you scattering into unexpected paths, just as the air does to light. And yet, from a distance, all those turns and detours become something coherent, something beautiful. Even the scattered blue has its limits. At the horizon, the light has traveled through more air, more molecules, more opportunities for the blue to be tossed away, leaving a paler, hazier tint. The world softens at the edges, as if painted with a gentle brush. It is here that the scattering begins to give way to other colors, a slow transformation that will, in time, set the sky aflame. For now, though, you linger in the midday stillness, where every breath of wind seems to polish the air, where every beam of sunlight carries a memory of the long, silent journey that brought it here. The air holds its ceaseless waltz with light, and you stand in the middle of the ballroom, bathed in the glow of a million scattered photons. In the quiet, you feel the pull of the horizon, a reminder that this same scattering will soon paint the world in fire. And as the light begins its slow, slanting descent, the air prepares for a different kind of dance. It begins not with darkness, but with a soft dimming, a gentleness that slides across the afternoon like a fingertip over still water. The heat that once shimmered on the pavement feels quieter now. Shadows lengthen, reaching across the ground like slow-moving tides. Above you, the blue you have known all day begins to change, as if the air itself is exhaling into evening. You notice it first in the light. It grows warmer, richer, as if every surface has been brushed with gold leaf. Trees seem to glow from within. The clouds, once pale and translucent, thicken with color until they resemble molten glass cooling in a kiln. And somewhere, deep in your chest, you feel a shift, a pull toward stillness, toward watching rather than doing. What you are seeing is a journey, not of the sun itself, which is steady in its own path, but of the light that reaches you. All day, sunlight has taken a short route through the atmosphere to your eyes. Now, as the sun lowers toward the horizon, the path becomes longer. The light must push its way through more of the Earth's air, more molecules, more particles. Every mile of this journey scatters the shorter wavelengths, the blues and violets, away from your view. It is not that they vanish. They simply spill sideways, diffused into the vastness of the sky overhead. What remains to travel directly toward you are the longer wavelengths, reds, oranges, golds, the colors that scatter less and thus survive the long passage. The physics of it is precise, but here, at this hour, it feels like alchemy. You can imagine each photon as a traveler carrying a particular shade. The blue photons are the sprinters, nimble but easily knocked off course by nitrogen and oxygen molecules. The red photons are the long-distance runners, heavier in their stride, less likely to be pulled aside. When the sun is high, you see all the runners at once, blended into the bright midday white. But now, in this slanting light, the sprinters have long since been scattered away, leaving the patient reds and oranges to arrive, unhurried but triumphant. Sometimes the effect is deepened by the very dust in the air. Tiny particles from faraway deserts, fires, or volcanic eruptions float invisibly, yet they catch the sunlight like fine nets. Larger particles scatter light differently than molecules do, bending and diffusing even the longer wavelengths so that the colors become more intense, more saturated. A hazy evening after a summer wildfire can bleed into a crimson so deep it seems to hum. Moisture plays its part as well. Water droplets suspended in the air can refract and reflect the warm light, softening its edges, blending one hue into another until the horizon looks painted in layers. Amber melting into rose, rose into violet, violet into the oncoming blue-black of night. In this hour, the air is no longer invisible. It becomes the medium of a painting, a living canvas that shifts with every breath of wind. The science says that scattering and absorption shape what you see. Your senses say it is something more, something human, something fleeting. You remember that these same sunsets have been witnessed by every generation before you. The ancient Greeks spoke of the rosy-fingered dawn and its evening twin, the wine-dark sea, under a reddened sky. Painters have chased it in oils and pigments, trying to pin down the precise instant when light is both vivid and soft. Lovers have stood in this glow, knowing that some part of its beauty comes from the certainty that it will not last. And it never does. The sun continues its descent, its light growing even more slanted. Soon the horizon swallows it entirely, and the last colors linger only in the higher clouds, where sunlight still brushes their tops while the ground below falls into shadow. This is when the colors can be most surprising. Purples that seem impossible, pinks that could not be mixed by any hand, gold so pale it is almost silver. From space, astronauts see this as a thin red band encircling the planet's edge at sunset, the sunlight passing through the thickest slice of atmosphere before bending into darkness. They watch it sweep around the Earth like the turning of a great clock, marking the boundary between day and night. Back on the ground, you feel the coolness settle in. The warmth of the colors is an echo now, fading into the deeper hues of twilight. The air smells different, fresher, more textured, carrying hints of earth and stone that have been warming all day. You hear the first evening insects tuning themselves for the night. The world is shifting its tempo. The last rays dissolve, and you are left in the afterglow, that in-between light that has no true color name. It is neither day nor night, but a breathing pause between them. The science of scattering explains the palette that has just unfolded before you. The part it cannot explain is the quiet ache you feel as the final streaks fade, replaced by the deeper blue of night's threshold. You lift your gaze again, and the horizon has softened into shadow. Above it, the sky holds a cooler tone now, a reminder that darkness is coming, yet without hurry. Somewhere, the first faint stars are waiting to be seen. You exhale, letting your eyes adjust, letting the warmth drain from the world as the coolness of evening takes its place. The night is not yet here, but it is close, and with it, a different kind of seeing, one that asks your eyes to adapt, to let go of color and embrace the subtle light that remains. The room around you is dim, but not dark. Somewhere between light and shadow, your eyes are doing quiet, intricate work you never notice unless you think about it. You blink, and for a brief moment, you sense that the world before you isn't just there, but is being built inside your mind, piece by piece, from the raw material of light. A tiny shimmer on the edge of your vision catches your attention. The glint is blue, soft, calming, familiar, and yet you realize you've never truly asked yourself how you are able to see that color at all. Your eyes are not windows. They are more like living cameras, with parts as finely tuned as the most delicate instruments humans have ever made. Light enters through the cornea, bending gently toward the dark opening of your pupil. The pupil widens or narrows in a slow rhythm, letting in more light when the world grows dim, less when the glare is strong. Past it, the lens curves and flexes, sharpening the image so that the rays converge on the thin, intricate tissue at the back, the retina. The retina is not a flat screen. It is a living forest of cells, layered and intertwined, each waiting to catch photons like leaves waiting for rain. Here, in this paper-thin layer, light is transformed into signals the brain can understand. And it is here that the story of blue becomes as much about you as about the sky. Two kinds of light-sensitive cells wait for the sun's touch: rods and cones. The rods, long and slender, are guardians of shadow, sensitive to faint glimmers in the dark, yet colorblind. They are the reason you can see under the silver light of the moon, though you cannot tell the color of the grass. Cones are their daylight counterparts, shorter, broader, and tuned to color. They are divided into 3 tribes, each sensitive to a different range of wavelengths, one for reds, one for greens, and one for blues. The cones for blue are the least numerous, scattered more sparsely across your retina. And yet, without them, the blue sky would be an impossible thing, nothing more than a dull gray. When a photon scattered by the air above you strikes one of these blue-sensitive cones, it triggers a change in the shape of a tiny molecule inside, called photopsin. That change starts an electrical ripple, racing along a nerve fiber toward your brain. But one cone alone cannot decide that what it saw was blue. Your brain must compare the signals from all 3 cone types, weighing the balance between red, green, and blue responses. Blue is not just detected, it is interpreted. It is a quiet kind of alchemy. The blue you see is not the blue that exists in the world. There is no blue floating above your head, no color pigment in the air. There are only light waves, scattered and bent, their energy measured in nanometers. Blue is a sensation your brain creates, a private reality stitched from electrical impulses. And because your cones respond differently depending on the light around you, your perception of blue shifts with the hour, the weather, the season. You've likely noticed this without realizing it. On some mornings, the sky feels almost pale, like worn silk. On others, after rain has washed the air clean, it becomes a deep, saturated blue, so rich you could fall into it. The difference is partly in the air, how many particles are there to scatter the sunlight, but also in you, in the way your eyes and brain adapt to the world's changing light. Your vision is not fixed. In bright daylight, the cones rule. They sharpen edges, heighten colors, let you read the subtle layers between azure and sapphire. But as the light dims toward evening, the rods begin to take over. This slow shift, called the Purkinje effect, is why blues and greens seem to glow at twilight while reds lose their fire. At the very edge of night, blue almost hums in your vision, though it is already fading to gray. This blending of biology and physics is ancient, older than you, older than humanity. Long before language, your ancestors could read the colors of the sky, not as art, but as information. A washed-out, whitish blue in midday meant dust in the air, perhaps from distant storms. A deep, clear blue promised fair weather. Even now, without thinking, you feel something shift inside you on a cloudless day. Blue light has been linked in your brain to alertness and energy, just as the dark invites rest. Some creatures see the sky differently. Birds, for example, have a 4th type of cone, sensitive to ultraviolet light, colors invisible to you. To them, the sky holds patterns and gradients you cannot imagine, like invisible rivers streaming overhead. Bees and butterflies use ultraviolet markings on flowers as signposts, glowing to them even under the noon sun. Meanwhile, many mammals, including dogs, see a far simpler sky, muted blues and yellows, without the richness of your human palette. The sky you know is yours alone, shaped by the quirks of your particular biology. And yet, even among humans, the perception of blue is not universal. In some cultures, the word for blue only emerged in recent centuries. Ancient texts often described the sky as bronze, or white, or simply bright. This was not because the people could not see the color, their eyes were no different, but because the brain learns to notice what it can name. Your experience of the sky is a conversation between your senses and your culture, between physics and memory. Think of the first time you really saw the sky as a child, not as background, but as something vast and separate from you. You might have felt a twinge of vertigo, a delicious unease at the sheer size of it. That feeling is part of the same neural pathways that read the wavelengths of light. Blue is not just a color. It is a signal, a mood, a fragment of the story your brain is always telling you about where you are. The more you dwell on it, the more astonishing it becomes. Every shade you see is the sum of photons' journeys, molecules scattering, cone cells' reactions, and the brain's quiet, ceaseless work. The next time you look up and feel the sky's color sink into you, you will know it is not merely above you. It is being created inside you, renewed every fraction of a second. Somewhere high above, the sunlight still pours through the air, scattering into waves too many to count. Your eyes drink in the result without effort, turning it into meaning before you even have words for it. And as the day leans toward evening, that meaning will change. The blue will soften, thin, and slip away, leaving room for another kind of beauty to take its place. A beauty painted not in light's shortest waves, but in its longest, warmest ones. It begins with a breath. Cool and steady, it moves through you, filling your lungs with the same invisible mixture that has surrounded every living thing on this planet for millions of years. You feel its gentleness, its quiet neutrality, yet in that ordinary air hides the secret of the blue above you. But imagine, just for a moment, that this breath was not the one you know. Imagine the air itself, its thickness, its weight, its chemistry, had been written differently in the planet's story. The sky you see each day would be an entirely new painting. In the world you know, our atmosphere is mostly nitrogen, with a generous helping of oxygen and tiny traces of other gases. Together, these molecules scatter sunlight in a way that favors shorter wavelengths, the cool blues that fall so softly over the world. But if you were to change the recipe, even slightly, the sky would respond like a prism turned to a different angle. Close your eyes and step into a thicker, heavier atmosphere, a blanket of gases that clings more tightly to the planet, much like the shroud of Venus. The light from the sun still arrives, still pours its energy toward the surface, but every photon must now push through a denser crowd of molecules. Blue light is scattered away almost completely before it reaches you. What remains is a suffused, diffuse glow, tinted toward yellow or orange, as though the day is always hovering near sunset. Shadows soften. The air tastes heavy, rich with pressure, and the horizon blends into the sky with no clear edge. You might feel as though you are living inside the dim light of a memory. Now lighten that atmosphere. Thin it until it is only a pale whisper over the surface, like the fragile envelope around Mars. Here, the sun's rays pass through with little interference. There is hardly enough scattering to produce much blue at all. The sky becomes a faded, dusty tan during the day, almost washed of color. The sun feels harsher, its edges sharp, shadows deep and unblunted. At night, darkness rushes in quickly, and the stars appear with startling clarity, even as the last traces of daylight cling faintly to the horizon. But chemistry can shape the sky even more dramatically than density. Picture an atmosphere filled with chlorine gas, toxic to life as we know it. But for this vision, you are only a traveler passing through. Chlorine scatters and absorbs light differently than nitrogen and oxygen, giving the sky an eerie green hue, as though the world is submerged in a sea without water. Every plant, every mountain, every human face would be cast in a perpetual emerald tint. In such a place, The concept of blue might be a myth told in stories, just as green is now woven into this alien air. Shift again, and you find yourself under the haze of Titan, Saturn's largest moon. The sunlight here is faint, only a fraction of what you feel on Earth, and it filters through a thick, golden-orange mist of hydrocarbons. The sky does not open above you. It feels close, intimate, like a lantern-lit ceiling. The light is dim even at noon, and colors on the ground are muted, drained by the amber glow. You could walk for hours in such a light without seeing a shadow that is truly black. Now you stand on a world rich in iron dust, like Mars. Here, the fine particles suspended in the air scatter sunlight toward warm, rusty hues. On some days, storms sweep across the horizon, and the sun itself appears as a pale disk in a copper sky. The air smells of minerals, dry and metallic, and every sunset is not the red you know, but a strange inversion, a moment when the sky turns blue for a few minutes, as fine dust scatters the longer red wavelengths away and lets the blues through. On Neptune, the farthest planet from the sun, the story shifts again. The blue there is deeper than Earth's, an intense, rich shade created not just by scattering, but by the absorption of red light by methane gas. That methane drinks the warmer colors and leaves the cooler wavelengths free to wash the atmosphere in a striking azure. Even in the thin light of a distant sun, the color is vibrant, almost electric. You would stand beneath it with the odd sensation that the sky is brighter than it should be for such a remote place. All of these skies, imagined and real, are shaped by the simple truth that sunlight is a mix of many colors, and the air decides which ones reach your eyes. Molecules, pressure, dust, and even the chemistry of alien clouds can all tilt the balance, sculpting the daylight into something utterly unique. This is why no two worlds are lit quite the same way, and why blue is not an inevitable feature of the universe, but a rare and delicate arrangement of conditions. There is something humbling in that thought. The shade you see every clear afternoon, the one you might take for granted, exists only because the Earth is exactly as it is, breathing the atmosphere it has kept for eons. If the planet had formed differently, if volcanoes had belched other gases, if the sun's light were slightly altered, the very mood of every day would change. Our language, our art, even our metaphors for joy or sadness might carry different colors. You think of how travelers on Earth marvel at foreign landscapes, deserts under pale yellow skies, islands under silver cloud cover, mountains where the air is so thin the blue fades toward black. Each place is a reminder that even on our own planet, the sky is never exactly the same twice. The light is always in conversation with the air, and the air is always telling its own quiet story. And perhaps that is why you feel a kind of intimacy with your own sky now. It is not just a backdrop. It is a delicate consequence of countless variables in the physics and history of our world. Its color is both a signature and a fingerprint, a reminder that the conditions for this beauty are rare and may not last forever. You let the vision of all those imagined skies settle in you, green like submerged forests, orange like lantern light, copper like Mars, deep sapphire like Neptune. They drift past you like dreams, each one painting the same sun in a new language. And slowly, you feel yourself rising in thought, moving upward toward a place where the color begins to fade, and the blackness of space waits quietly beyond. The air tastes sharper here, cool against your lips, the way mountain mornings hold a crispness that wakes every sense. Around you, the familiar fullness of blue begins to pale, washed thin as if the color were being drawn away by an invisible tide. You can almost feel the sky stretching, opening, loosening its grip on the day. The warmth of the ground below seems far away now, and with every breath, there is a little less of it to hold on to. The thinning air is not empty, but it is less crowded. Molecules that once danced in thick, busy gatherings are now sparse, like scattered guests after a party has ended. Each photon of sunlight that arrives has fewer partners to collide with, fewer chances to scatter into your eyes. The blue that once wrapped the world begins to fade into a deeper, more uncertain hue, a gradient that slides toward indigo, then violet, then something that is not color at all, but absence. You rise with the knowledge that the blue you've always known is a kind of mirage, born from abundance. Down below, nitrogen and oxygen molecules wait in their countless trillions, breaking sunlight into its spectrum and sending blue in every direction. Up here, those same molecules are so few that much of the light sails past unbent, unscattered, heading onward into space. The veil of color becomes thinner than the sheerest fabric. Mountaineers speak of this transition. They tell of summits where the horizon curves slightly and the blue above is darker than it has any right to be in midday. On peaks like Everest, 29,000 feet above sea level, the air is only about a third as dense as at the shore. Not only does this make breathing harder, each inhale a shallow sip instead of a deep gulp, but it also changes the way the world is lit. Shadows here feel sharper, the light more direct, because there is less atmosphere to soften and scatter it. Pilots see it too. In the cockpit of a high-altitude jet, the view is not the pure azure of postcards. Instead, the sky deepens, shifting to a velvety indigo, even when the sun blazes overhead. Above about 60,000 feet, the domain of aircraft like the State Route 71 Blackbird, the day already begins to look like night. The boundary is not a hard line, but a slow bleed from one reality into another, a gradient measured in miles and minutes. And then there are the astronauts, who have seen the last threads of blue unravel completely. At the edge of space, the Earth's atmosphere appears not as a ceiling, but as a thin halo clinging to the planet's surface. Against the blackness, that halo glows faintly, not opaque, not infinite, but delicate, as if it could be brushed away with a fingertip. From low Earth orbit, you see that our atmosphere, which feels so vast from the ground, is almost nothing compared to the size of the world. If Earth were the size of a basketball, the breathable part of our air would be no thicker than a coat of varnish. You drift in thought, realizing that space does not truly begin at a sharp altitude. The Kármán line, often set at 62 miles above the surface, is a human-made marker, a convenient number in a sky that knows no boundaries. In reality, the atmosphere thins gradually, layer by layer, until the molecules are so far apart that a single atom could drift for miles before touching another. There is no doorway to space, only a long, slow fade from air to emptiness. This fade is why the blue recedes. Scattering depends on interaction, and interaction depends on density. When the molecules are too few to deflect much sunlight, the sky stops glowing with color. Without that scattered light, you see the universe for what it truly is, not a bright, painted dome, but a void lit here and there by distant stars. The blackness isn't new. It has always been there, even at noon. The blue was simply a veil, hiding the infinite behind it. There's something humbling in that. The black of space is not far away, not distant in some unreachable realm. It begins just above your head, waiting behind a curtain of molecules. And the blue you have known all your life is a gift from the air, a kind of kindness that keeps the void at bay, softening the sun's harsh light into something the human eye can bear. As you imagine yourself higher still, perhaps in a capsule ascending through the stratosphere, you feel the pull of gravity weakening in your senses, if not in truth. Your body still belongs to the earth, but your vision belongs to both worlds, the warm, scattering air below and the silent, star-pierced dark above. The sun here is not the yellow-white disk you remember. Without an atmosphere to diffuse its rays, it burns in unflinching white, surrounded not by blue but by black, as if a hole had been cut into the sky to let it through. Even the way shadows behave changes. On Earth's surface, they blur softly at the edges, gentled by light arriving from many scattered directions. Up here, shadows are knife-sharp, etched in high contrast, because the sunlight travels in straight, unbroken paths. A hand raised before you casts a silhouette so crisp it feels like a drawing. It is in this place between worlds that the colors of Earth become most precious. Looking down, you see the oceans shimmering in deep sapphire, the continents tinted with greens and browns, the clouds trailing white ribbons across the planet's face. Around it all, the faintest blue ring, the edge of the breathable world, clings to the curve of the globe like a fragile breath. And yet, you know the blue will not follow you farther. Beyond this edge, the photons that once scattered to meet you will continue on, unbent, until they touch the moon or vanish into the great cold between stars. The light here no longer belongs to the Earth, it belongs to the cosmos. You exhale slowly, letting the thought settle that the difference between day and night, between blue and black, is not a matter of distance but of presence. The presence of air, of molecules in motion, of a living planet's invisible shield. Without it, the sun would be blinding, the stars eternal, and the world uncolored. A quiet stillness gathers in you, the kind that comes when a truth is both vast and gentle. The air has thinned enough for space to whisper in, not as a cold intruder, but as an endless horizon. Here, the boundaries dissolve. Here, the sky and the universe touch without seam or shadow. In that meeting place, your gaze turns outward, toward the dark that once puzzled astronomers. A darkness that is not empty, but alive with secrets. Darkness feels complete only until you begin to notice what hides within it. You stand beneath a night sky on a clear, still evening, the air cool against your cheeks, the faint scent of damp earth rising from the ground. Above you stretches a tapestry of stars, countless points of light, each steady and ancient. At first glance, it feels vast and unending, yet quiet, as though the black between the stars is a permanent truth. But then a thought stirs. If the universe is filled with stars, scattered in all directions, should the darkness not be blazing with light? Should every inch of that black canvas not be stitched with fire? The question feels like a small stone dropped into a deep well. It ripples outward through history. Long before electric light, before city glow and street lamps, the night sky was sharper, deeper, more crowded with stars than most people today will ever see. It was a sight to stop you mid-step, to make you tilt your head back until the muscles in your neck ached. And even then, even with more stars than you can count, there was still blackness between them, vast and untouched. This emptiness was the seed of a riddle that would puzzle great minds for centuries. You imagine the old thinkers, Kepler, Halley, Herschel, lifting their eyes to the heavens and trying to reconcile what they saw with what they believed. If the universe had no end, if stars went on forever, then no matter where you looked, your line of sight should eventually land on one. The sky should blaze as brightly as the surface of the sun itself. There should be no night. And yet, night persisted. This puzzle, simple in its phrasing yet profound in its consequences, asks you to see the universe in a new way. Close your eyes and imagine the cosmos as infinite and eternal, every speck of space occupied by a star. The light from all those suns would overlap, layer upon layer, until darkness was impossible. Every shadow would vanish. But when you open your eyes to the real sky, there is silence in the gaps between stars, a darkness that holds its own presence. Something is missing. You begin with the first layer of the answer. The universe has not existed forever. Its age is finite, around 13.8 billion years. That number is vast beyond imagining, yet it is not infinite. Light travels at a set speed, 186,000 miles every second. And though that feels instantaneous in your daily life, it means that light from the most distant regions of the universe simply hasn't had enough time to reach you. The darkness, then, is partly the silence of light still on its way. But that is only the beginning. As you let your thoughts drift further outward, the second truth comes into focus. The universe is expanding. Galaxies are not fixed like gems in a velvet cloth. They are moving away from one another. The farther a galaxy is from you, the faster it recedes, and its light is stretched into longer wavelengths, a phenomenon called redshift. Some light is shifted so far that it slips beyond the visible spectrum entirely, into the faint murmur of infrared or radio waves. That light exists, but your eyes cannot see it. The darkness between stars is, in part, light stretched out of sight. And then there is the fact that not every place in the universe is filled with stars. Much of space is empty, or nearly so, and stars themselves live finite lives. The brilliant points you see above you are temporary, in cosmic terms, fragile. When they die, they leave behind cold remnants, silent as ash. The night sky is a map not only of where stars are, but of where they are not, and of where they no longer burn. You think of the oldest light in existence, the cosmic microwave background, the faint afterglow of the Big Bang. It comes from every direction, a relic of when the universe was only 380,000 years old. But it is not bright to human eyes. It glows in microwaves, a hidden whisper of heat only detectable with instruments. To look up and see darkness is, in a way, to look past the universe's first light, now stretched thin and cooled by time. The more you learn, the more the darkness changes shape. It is no longer just absence, it is evidence. It speaks of beginnings, of expansion, of distances so great that human language strains to hold them. It tells you that what you see is not all that exists. And in that way, the black sky is as much a wonder as the stars themselves. You picture yourself floating in space, far from Earth, where the sun is a distant glare and stars pierce the void from every direction. Even there, surrounded by suns, you would still see blackness. The light is there, countless beams crossing the cosmos, but your eyes can only catch the few that travel directly toward you, unobstructed. The rest passes unseen. The universe is full, but you experience it as sparse. This paradox, once a source of confusion, now feels like a comfort. Darkness is not a failure of the universe to be bright. It is a reminder that you stand in a moment, in a particular place, seeing just a fraction of the whole. To live is to have horizons, boundaries on what you can perceive, and to sense that beyond them lies more than you can imagine. As you stand there, your gaze softens. The black sky seems less like a void and more like a deep ocean, one that cradles islands of light. The stars are no longer scattered randomly. They are set against a background that holds them in quiet balance. You can feel the age of the universe in that darkness, the slow drifting of galaxies, the patient journey of light. The air around you cools as the night deepens, the faint chirp of insects settling into the rhythm of the hours. You breathe in, and the scent of grass mixes with the mineral tang of stone cooling after the day's heat. Somewhere, unseen, a breeze moves through the leaves. The stars overhead do not change, yet the darkness feels alive now, filled with the unseen stories of light on the move. And as your eyes adjust more and more to the dimness, you notice the faint smudge of the Milky Way arcing above, a river of light made from billions of suns, each far away, each sending its light across impossible distances. Between its bright clusters are pockets of shadow, not empty at all, but hiding dust clouds, stellar nurseries, and distant galaxies you cannot see. The interplay of light and dark becomes a language, one you are only just beginning to learn. In the stillness, you sense that darkness is not an ending but a threshold. Beyond it waits light too far, too slow, too faint for your eyes, yet still it moves, still it travels, still it exists. The night around you becomes a meeting place between what reaches you and what is yet to arrive. And so you stand, eyes open to the black between the stars, feeling the weight of its quiet, and letting it carry you into thoughts of how vision itself changes when the sun is gone, and the world turns to shadow. The night settles over you like a slow breath, and the world begins to lose its edges. Shapes you knew in daylight now soften, fading into gradients of gray. The color drains away not all at once, but in a gentle unthreading, until even the brightest red becomes a whisper of shadow. In this dimness, your eyes are changing, quietly rearranging themselves to match the darkness. Within your retina, the cone cells, the ones that feast on daylight, that let you see the bold blue of a summer noon or the sharp green of new leaves, begin to rest. They are not built for this hour. Instead, their quieter cousins awaken, the rods. There are far more of them, scattered across the edges of your vision like a watchful crowd. They cannot tell you what color something is, but they can find it in the dark. They are more sensitive than cones by orders of magnitude, able to catch the faintest drips of light, sometimes even a single photon. You might imagine these rods as the sentinels of night, each tuned not to hue but to brightness. Their chemistry shifts with your surroundings. A pigment called rhodopsin builds in them when the light is low, making them exquisitely sensitive. But that sensitivity is fragile. A brief flash of white light can bleach it away, taking minutes or even hours to rebuild. This is why sailors once navigated with red lamps and astronomers shielded themselves with crimson filters. Red light slips past the rods almost unnoticed, leaving them ready for the stars. As your eyes adapt, the world takes on a silvered quality. The full moon becomes almost too bright, painting shadows on the ground that seem sharper than in daylight. Even under starlight alone, your rods work quietly, amplifying what little there is, letting you trace the line of a tree against the sky or the ripple of water against stone. It is a different kind of seeing, slower, less certain, but richer in subtleties. Your central vision, ruled by cones, still clings to the last shreds of color, but at the edges, where the rods reign, you are more sensitive to motion. That is why a faint meteor might appear out of the corner of your eye, only to vanish when you look straight at it. In the dark, your vision works best like an artist's brush, sweeping gently across the canvas instead of staring at a single point. You may not notice it, but your pupils widen in the dark, opening like small black flowers to gather every drop of light. This is the body's most visible gesture of trust toward the night. Behind them, the lenses bend the incoming light toward the retina, delivering to your rods and cones the patterns the brain will transform into an image. But in darkness, the brain must work harder, filling in what is missing, making guesses from the fragments it receives. Some creatures do this far better than you. Cats, for instance, have a reflective layer behind the retina called the tapetum lucidum, bouncing light back through their photoreceptors a second time. This is why their eyes flash green in the dark. They are, in a sense, doubling their night vision. You, by contrast, rely on patience. Human night vision is not instant. It deepens minute by minute, each rod cell slowly waking, each neural pathway sharpening for the low-light task. And in this patience lies a hidden gift. As the rods take over, the night sky itself seems to grow. You begin to notice stars that were invisible at first, the Milky Way becoming a pale river flowing overhead. You might even see the faint smudge of the Andromeda Galaxy if the air is clear, light that left its source more than 2 million years ago, landing tonight on the delicate chemistry inside your eyes. Your sense of time loosens here. There is no glare to mark the minutes, no clock in the sky, but the turning of constellations. You find yourself breathing more slowly, the quietness of vision spreading into the rest of you. The night's darkness is not an absence, but a presence, a soft, enveloping medium in which your senses stretch in new directions. Smells sharpen, carried more vividly in the cool air. Sounds travel farther, crisper, as if they too are freed from the harsh competition of daylight. The crunch of gravel under your foot, the distant rush of a stream, the faint rustle of leaves all seem nearer, stitched together with the dim patterns your eyes collect. You are no longer just looking, you are inhabiting. Even the darkness between stars feels alive. It is not truly black, not to your adapted vision. It carries the faintest shimmer, a whisper of scattered starlight, of unresolved pinpoints your rods cannot quite separate but can still feel. Astronomers sometimes call this the airglow, a gentle emission from atoms high in the atmosphere, releasing energy absorbed during the day. It is like the Earth breathing light back into the night. This, too, is why the sky on the darkest night is never as black as the void seen from space. Here, you are wrapped in an atmosphere that catches and cradles even the faintest illumination. It softens the universe, tucks it closer, and lets you look at it without being overwhelmed. You may recall moments when darkness felt absolute, in a cave, perhaps, or in the middle of the ocean on a moonless night. In such places, with no photons to collect, the rods surrender, and you experience true visual silence. But here, under the open sky, there is always something. Your eyes in the dark are like nets in a wide, star-filled sea, catching what they can and letting the rest drift past. You begin to trust the dimness. You learn to move without glaring light, to see with gentler eyes. This way of seeing feels older, more primal, as if you are borrowing the vision of your ancestors, those who walked under constellations long before cities carved their glare into the night. Above you, a star winks into view that you had not noticed before. Its light is faint, fragile, yet it has traveled across unimaginable gulfs to arrive here, to find you in this moment. You wonder how many others are watching it now, their eyes making the same slow adjustment, their minds quietly mapping the darkness. You feel the night vision deepen until it is no longer just about sight. It is about being in the night, about becoming part of the low light, the cool air, the slow rhythm of darkness. And somewhere above, curving around the planet, is the thin boundary where the blackness of space meets the final traces of blue. Without knowing it, your gaze begins to drift toward that place. It begins as a whisper of light on the horizon, a slender ribbon bending around the planet's curve. You are not on the ground now. You are far above it, moving in slow arcs over continents and seas, looking down at the world as if it were a jewel cupped in darkness. The sun's edge lifts from behind Earth, and there, along the rim, a glowing thread appears. It is not solid. It is not still. It shimmers like breath against glass, a delicate line of blue so thin it feels impossible that it could hold all the storms, forests, and cities below. Yet it does. The halo is brightest when the sun is just beyond the horizon, its light cutting tangentially through the air. At this angle, sunlight passes through hundreds of miles of atmosphere, scattering the shorter blue wavelengths into your line of sight. From here, the color seems pure, almost electric, because your eyes are no longer looking through it, but at it, a sideways glimpse into the very skin of the world. You lean closer to the glass of the observation window, though there is nothing closer to lean toward. The planet is still hundreds of miles beneath you. The blue looks soft enough to meld into, but you know its softness is only an illusion. That glowing veil is made of molecules moving faster than bullets, colliding, ricocheting, exchanging heat, light, and momentum. You imagine yourself drifting down into it. First through the exosphere, where a single atom might travel hundreds of miles before touching another, then into the thermosphere, where charged particles from the sun dance in auroras. It is strange to think that almost all the air of Earth, all the air you have ever breathed, lies within just a few miles of the surface. From up here, the atmosphere is like the thinnest wrapping around a sphere, fragile enough that if it were scaled down to the size of a classroom globe, its breathable layer would be no thicker than a coat of varnish. And yet, this film holds oceans in place, shields life from deadly radiation, keeps temperatures steady enough for rivers to flow. As the station moves in silence above the planet, the halo changes. Over the oceans, it seems more saturated, as though the water below reflects back some of the blue. Over deserts, the band is lighter, tinged faintly with gold from fine dust scattering longer wavelengths into the mix. If you could float here for a day, you would see the halo throb and shift with storms, volcanic eruptions, and the seasons of the planet. In this stillness, you think about the countless generations who never saw the sky from above. To them, blue was infinite, a ceiling without an edge. They could not have imagined that it was only a sliver of gas. It was the age of rockets, satellites, and space stations that finally gave human eyes this view, and with it, the humbling realization that our world's atmosphere is both protective and perilously thin. You trace it in your mind like a ring of glass, one that could shatter under neglect. Every breath you've ever taken, every gust of wind that's ever carried seeds or song, has been held within this glowing line. It is not just a border between air and space, it is the boundary of home. Scientifically, the blue halo exists for the same reason the daytime sky does, rayleigh scattering. The sun's light contains all colors, but when it grazes the edge of Earth, it is passing through far more air than when it falls overhead. The shorter blue wavelengths scatter in all directions, many of them sideways into your eyes. Longer wavelengths, red, orange, yellow, keep going straight, passing deeper or slipping beyond the line of sight. That's why the halo is not a rainbow, but a distilled blue, sharpened by the path it takes through the atmosphere. Yet there's another layer to its beauty, the way your eyes, unencumbered by ground and horizon, register the contrast between the halo and the void behind it. Space is so black it seems to swallow light whole, and this makes the blue flare brighter, more alive. Your mind loves contrasts, it feels them like music. The quiet between notes makes the next note more vivid. The darkness between stars makes the stars more fierce. Here, the black makes the blue ache with color. You imagine following the curve of that halo all the way around the planet. At orbital speed, you would circle Earth in about 90 minutes, watching the blue rise and fall with each sunrise and sunset. Sometimes it would be sliced by clouds, sometimes faintly doubled by reflections in the station's glass. You would notice that at certain moments, The halo seems almost layered, a deep indigo at its outer edge, fading into turquoise, then a pale, delicate silver near the surface. These layers are not tricks of the eye. They are signatures of the atmosphere's structure, the way light scatters differently in the mesosphere, stratosphere, and troposphere. In the quiet of the cabin, you feel the slow turning of the planet beneath you. You can see an entire coastline curve like a sleeping giant, rivers glinting in the last light, cities beginning to glow in gold. Above them, the blue halo remains, holding back the infinite. It is strange comfort, the kind you only feel when you see something fragile and know it has endured for billions of years. A meteor might burn in the upper atmosphere below you, a brief spark in the darkness. That burning is another gift of this thin layer. Without it, meteors would strike the ground at full speed, oceans would boil away under the sun's ultraviolet glare, and life would be stripped bare. The halo is both ornament and armor. Still, it is not unchanging. You know that human activity has been altering its chemistry, thinning the ozone that shields against harmful radiation, adding greenhouse gases that trap heat, shifting its balance in ways that affect the entire planet. From space, there is no border, no visible warning line, only that beautiful, unbroken blue. The thought is a reminder, as soft as it is urgent, that beauty and fragility often live together. You let your eyes rest on the halo until it begins to fade. The station is moving into night now, the sun slipping below the far horizon. The blue drains away, replaced by the thin gold of the upper atmosphere, then by the silver white of the moon's reflection on clouds far below. In moments, the edge of the planet will be nothing but a silhouette against a star-filled void. And yet, even when invisible, the halo remains, cradling the world in light you can no longer see. Somewhere below, wind will carry the scent of rain over a city, leaves will turn toward the sun, and the sea will rise and fall under its steady protection. As darkness gathers, you feel your gaze drawn outward, past the curve of Earth, into the endless black where other worlds turn in silence. Somewhere out there, skies glow with colors you have never seen, under suns that scatter their own unique light. You find yourself wondering, and in that wondering, you drift toward the thought of those far-off horizons. The first thing you notice is not the color itself, but the feeling it leaves inside you. Standing on the imagined surface of a world far from home, the sky above bends light in unfamiliar ways. It is as though someone has turned the dial on reality, shifting the palette until even your own memories feel foreign. You breathe in, and though the air is not always for breathing, your mind fills it with scent, sharp, metallic, or sweet with methane haze, as your eyes drink the view. On Neptune, the blue is deeper, cooler, more secretive than the one you know. It is born not from scattering alone, but from the very molecules in the air. Methane absorbs the reds and yellows of sunlight, leaving the higher, ghostly blues to drift into your eyes. You stand at the edge of a planet where winds scream faster than any hurricane on Earth, yet here, in your stillness, the color feels like a quiet song. It is a reminder that even in the farthest reaches, the sun still paints, though with a hand changed by distance and chemistry. You close your eyes and feel the pull of another place. When you open them again, the horizon is thick with haze the color of ripe salmon, glowing softly in a muted twilight. This is Titan, Saturn's largest moon, and its air is heavy with nitrogen and methane. Sunlight here is faint, arriving after a billion-mile journey, filtered through layers of golden mist. The haze scatters what little blue there is, letting only the longer, warmer wavelengths through, so the world is bathed in a perpetual sunset. You imagine walking here, every step muffled by the thick air, your own shadow blending into the amber glow. It feels less like standing on a moon and more like moving through a dream you once had, long ago, where the air was dense enough to carry secrets from one breath to the next. The shift is more sudden this time. The warmth of Titan's haze gives way to a colder, thinner sky, tinted with a copper that reminds you of desert sands under a fading sun. Mars stretches before you, a planet where the sky is shaped by dust. Tiny particles of iron oxide float in the air, scattering sunlight in ways your Earth-trained eyes find strange. Here, the blue hides near the sun itself, a pale halo in the midst of the copper, because the dust prefers to bend and hold the red light instead. At night, the thin atmosphere can no longer keep the warmth, and the black of space presses closer than you have ever felt, as if the stars are leaning in to listen. Each sky tells you not only about the light, but about the world it belongs to. You begin to see that color is never an accident. It is a story told by gases, dust, distance, and the hunger of each molecule to capture or release a certain piece of the spectrum. On Venus, though you do not stand there now, the clouds would swallow nearly all visible light, leaving a pale yellow-white veil lit by a sun you could never quite see. On Pluto, the sky would surprise you with a faint blue at certain angles, caused by tiny particles suspended high above the ice, scattering light in a way that feels like a whisper of home. The science is gentle, unfolding in layers. You remember that light from the sun carries all colors, each a different wavelength. When this light meets an atmosphere, the molecules and particles decide which colors will pass through, which will scatter, and which will vanish into absorption. This is why no two worlds share the same shade. A simple change, swapping nitrogen for methane, dust for haze, can turn a bright midday into a muted gold or a deep, brooding indigo. But it is not only the atmosphere that shapes what you see. Distance changes the angle of sunlight and the amount of light at all. A planet far from the sun receives weaker light, so even the brightest colors feel subdued, as though someone has drawn a veil across them. Gravity changes things too. How thick an atmosphere can be, how long particles can linger before settling. And then there is time itself. Skies evolve as worlds change. The copper of Mars was once, perhaps, a truer blue when its air was thicker and its rivers still ran. You begin to notice something more personal in all of this. These alien skies remind you that color is not a constant truth. It is an agreement between light and matter, one that could have been written differently for your own world. The blue you know is not inevitable. It is a fragile outcome of just the right gases, just the right scattering, just the right sun change one element, and the ceiling of your childhood afternoons might have been green or gold or entirely black. There is a quiet comfort in realizing this fragility. It means your sky is precious not because it is permanent, but because it is rare. It means that when you look up, you are seeing the fingerprint of a very specific set of cosmic coincidences. Neptune's blue, Titan's haze, Mars' copper. They are the signatures of other arrangements, other possibilities, each beautiful in their own way, each belonging perfectly to the world that holds it. You think of the explorers who have seen more than one sky with their own eyes, the astronauts who watched the blue halo of Earth fade into the ink of space, and the robotic probes that sent back the first colors from far-off worlds. Through them, you have already glimpsed other dreams. Perhaps one day, someone will stand on Titan's surface and watch the sun rise through its salmon mist. Perhaps someone will walk the dusty plains of Mars at dusk, seeing the blue light cling to the sun before it slips away. You linger in the thought that each of these skies is part of the same universe, your universe, and that no matter their color, they are all lit by the same distant star. The light leaves the sun without preference, carrying every hue, and only upon arrival does it choose its story. It is a reminder that beauty is often not in the source, but in the meeting. The air around you grows softer, the imagined horizons dissolving into a seamless wash of color and shadow. You can no longer tell if the light you see belongs to Earth or some other world entirely. All that remains is the sensation of space, vast, quiet, unbroken, and the knowledge that somewhere out there, other skies are turning slowly above other worlds, each carrying their own dreams across the long night. You rest now, carried by the slow rhythm of your own breathing. The colors you have gathered tonight, the blue of home, the copper of Mars, the gold of Titan, the deep indigo of Neptune, drift together like pigments in water, merging into something both familiar and strange. You understand, at last, that the sky is not a fixed thing, but a meeting point between light and the matter that greets it. Above you, on Earth, the air still scatters the sun's shorter waves, gifting your eyes the tender blue that has followed you since childhood. Beyond that, in the openness of space, darkness stretches without end, lit only where stars dare to pierce it. And yet the black is not emptiness. It is the canvas on which all light exists. As you let your eyes close, you feel the vastness folding gently around you. Daylight and starlight, air and void, color and shadow, all are part of the same story. You have walked between them, and now you carry both in your thoughts. The blue is the voice of daylight, the black is the voice of forever, and in their quiet conversation, you find your place.